Welcome to exercise 17, where we get into heap versus stack memory allocation. You know, from the previous exercise, I had you go and sort of like stumble around, find out what does it mean to be heap versus stack. So the best way to describe heap versus stack, just really simply, anytime you call malloc, that's heap. Everything else is stack. Now that gets a little weird because there's a lot of other memory addressing areas. It's not always the stack. For example, if you have variables that are defined in a file here, they might be stored differently. But for practical purposes, you just worry about the heap. Everything else is going to be, static allocations, stack, very similar. The implication of the difference between heap versus stack is when you pass in a structure like this on a function, if you don't use a pointer, so if you get rid of that, you're passing a full structure. The structure can take over a bunch of the function call stack. And that means it will use more space. It also has to be copied onto the stack. So now we get into call by value versus call by reference. For this exercise, though, all you're doing is using the stack for just, simple addresses, like, see how that's an address and so on. And you're using the heap to pass around structures that need to be shared among things. So the plan in this exercise is learn to allocate data on the heap, memory management techniques to avoid leaking, and how the heap differs from the stack and when to use them. So let's look at the code. I'm not going to analyze this code fully because one of the things about this exercise is you have to figure out this code. That way, when you figure out this code, you will have a better understanding of it. It's the longest program we've done so far, and it does sort of a quote-unquote realistic thing. It's a database. So you want to make sure that you can understand how this works. However, for the first task, which is how to do allocating on the heap, I'm going to point out some things to you. All right, so first thing, when we do database open, I'm making a structure with malloc. That's heap. Got it? Now, same thing here. When I make the database struct, and I'll pop back up here, our structure is composed of a connection that has a pointer to a database structure. And the database has not a pointer to. It actually has a full array of address elements. That's the key difference. This is just a pointer to the database, so we malloc it up. But when I call malloc, it's going to actually malloc this, and max rows is 100, so it'll do 100 addresses, and each address has 512 size character and a 512 size email. So that's 100 times 512 plus a size of 2 ints. It's a full, huge chunk of RAM. It is not malloc. So that's where we're starting to get into our clue. This here is on the heap. Later, we make things on the stack. Okay, so we've made our database. This is going to be large because it's the full database structure. Now we open some files. So you start getting into file opening. Again, go read up on that. We cover a lot of that later, but I introduce you to things by just throwing them at you and have you try it. And then I'm passing the pointer to loads that it loads it. At the end, I check that the file worked and we're good. Now, when we close, it's sort of the inverse. If I have the connection, I go in and I close the file and I free the database. But because we allocated a whole chunk of RAM on the thing instead of like each individual address, it's all just done in one spot. Next, when I write, I take and I rewind the file, go and look at that, and I write the whole database structure. Study this, because what ends up happening is this thing here, the size of here, is actually really large. It's the size of the file. You'll see. We'll do it in a little bit. Create, then, is going to make me a new one. And notice what I'm doing is I'm looping through. This is the syntax to create an address and see that there's no pointer. It's on the stack for this function. See the difference? If I use malloc, it's heap. If I don't use malloc, it's stack. Really quickly, what is meant by stack is the function itself has a chunk of RAM that's called the stack. And that chunk of RAM stores this and stores this. And what that does is when the function exits, that memory is automatically cleaned up. You don't have to free that memory. Later on, you'll actually implement a stack, and you'll see what I mean. We'll do a data structure. Okay, so now I go through and I'm just sort of like setting some default values for address. Next, I set a value. This goes through and shows you how it's setting a value. Again, study these things on your own, figure this out. And get, I'm doing get. Okay, so what is this? This is strange. I'm getting the address of the connection database rows ID. You can break this down. It's very straightforward. First, I have to get the connection, the element, the DB element out of it, and then the rows out of the database. And then whatever this integer ID is, that gives me that whole thing gives me one address, and then I get the address of it. So that gives me a pointer to that one element. So then I can call address print on it, passing that pointer to it. Now I do a delete, same sort of deal. The delete, though, because I didn't malloc each address element, all I have to do is just overwrite it. So the easiest way to overwrite it is just to create an address like this, and then just assign it to that row. And remember, this here is how you can set elements of a struct ahead of time. So very handy. It used to be terrible doing this. In fact, most of the time, if you see people doing something like this, and I'm actually going to get this wrong the first time. This is how error prone this is. Yeah, see, I don't remember how this is. So it's the destination, the source, and the size. You wouldn't believe how often people get this wrong. Another one they get wrong is called memset. Okay, that's how you used to do setting one structure to another. But this is stupid because the compiler can basically just do this for you. And this is for copying memory around. And this is how people used to assign structures to each other. You don't need to do this anymore. The compiler, if it wants to do that, will do that. All you have to do is say assign one address to another. If address was a pointer like that, then you would just say the value of address, assign it to that. You don't have to do memcopy on addresses anymore, on structures anymore. Okay, so now we list it. Pretty simple, nothing big there. And then finally, the main function is processing using your switch statement and going through case by case for command line options. Okay, you need to go through that and definitely make sure you understand each line. I would go through this, and remember, one of the ways you want to type code is to not type in this whole whack of code and then expect it to work right. You want to do a little bit at a time. So first thing I would do is I would get the structures typed in, make sure they compile, and a fake main function. Then I would do, say, address print, these address functions. Get that to work. Get die to work. Just use the main to run them. Then get open to work. And I would get open to work in little bits each time. Little piece by piece by piece. Then get close to work, little piece by piece. Then get write to work. And set and so on, little piece by piece. Then come into main and get this part to work. Then get the first switch statement to work. Then get the second switch case to work. And then get the third switch case to work. Do them piece by piece, a little bit at a time. And that's an easier way to type it in and learn it. Okay, so let's see. Make EX17. And let's just run it really quick. Okay, we get our usage error. It's telling us DB file action. Okay, so our first thing we want to do is create. So we do EX17. DB file is test.db and create. Now let's do this. Let's see what we got. That's how many bytes this file has. So if we open this up in Vim, see, it's all binary. It's similar to when you opened up that one of the compiled programs you made. There's no text in it. Okay, so let's see what we want to do. Let's do the next one. let's set something. Okay, so we want to do set, and we need to have a name and an email, an ID, a name, and an email. So let's do 0 z test@test.com. Okay, that worked. Let's make sure that it fails though. Need ID. All right. Now let's load that back up and see my name shows up and test.com shows up. So this is one address record and this is another address record. See how it's organized? These are all zeros. These things here look like zeros. Pretty interesting. Now let's do get. So we want to do G and 0. And that prints it out. Let's delete one. Let's do delete 0 and then try to get it. ID is not set. Now let's go set Z and let's do Frank and Mary. And then let's list it. Okay, so that's how yours should work. And again, go through piece by piece. Another way to do this piece by piece would be to implement the main function with all your cases, but then don't put the contents of the case until you're ready until you have that function working. So make one function at a time and one case statement at a time work. All right, for breaking it, I'm going to leave this to you. I'm not breaking it in this video because the code was much more involved, so I had to go through actually exploring it, and you should be able to do most of this stuff. But remove all the safety checks. That's a very big one. And you'll see what that does. There's some safety checks in it. Corrupt the data file, see what happens. Can you mangle this thing? Pass bad arguments to the program. Check out strn copy and see what that does. Argument, in extra credit, have the database do arbitrary sizes. You'll see though that's going to cause some problems. So you'll have to see what happens when you do that. Okay, for the extra credit, the die function doesn't work so well. So let it make it so that you can pass the connection variable and it will do a close if it exists. Have max data and max rows be a parameter to the create function, and then make it so that you can do the dynamically sized one. That'll be interesting because if you're taking the max rows and max data from the command line, that means someone can make you allocate something really huge. So should you have limits? Add more operations you can do to the database, like find. So given a piece of text, find some part of the database. That's a for loop and some string comparisons. It should be easy. Read about how C code does its struct packing. So there's like a pretty straightforward structure packing that C adopted that pretty much every programming language just grabbed because C became the de facto. Add some more fields to address and make them searchable. Write a shell script that will do your testing automatically for you. Try reworking the program to use a single global for the database connection. How does this new version of the program compare to the other one? So do you have to keep passing the connection around, or can you just use one? Incidentally, that is a bad design, so keep that in mind. Go research stack data structures and write one in your favorite language. Then try doing it in C. We do this in C at the end, so try it out. See if you can make a stack data structure. You'll see what I mean. All right, that's the end of lecture 17. I'll see you at the next exercise.